Alright, welcome back. Working with a new setup here today. If you prefer this darker background, please let me know. If you want me to switch back to the lighter one, also let me know. I just want to figure out what's better for y'all to watch and what's easier on your eyes. Today we're going to be talking about radical equations. Now, radical equations are any equation where you have your variable stuck underneath a radical. That could be a square root, that could be a cube root, that could be a fourth root. It doesn't matter. As long as there is a radical in there, you'll follow the same basic steps. Just like in any other equation, we are going to isolate our variable by peeling out the operations around it. And the way we undo a radical operation is we raise it to the corresponding power. So if it is a square root, we will raise it to the second power. If it is a cube root, we will raise it to the third power. Fourth root, we'll raise it to the fourth power. And today we're just going to be working with square roots, but like I said, anything that we do today with the square roots will translate over exactly into doing the same thing with cubes, doing the same thing with fourth roots. A couple of other things to note. When you are working through these problems, there is a very high likelihood that you will come across a quadratic that you will need to then find the roots of to find solutions. If you're not comfortable with factoring quadratics, I've got a few videos on that. I will link them down in the description below. Something else to note is when solving out radical equations, you can wind up with what's called extraneous solutions. If you wind up with the square root of a number is equal to a negative, this is an example of why you would get an extraneous solution. Because whenever we take the square root of something, we're looking for what's called the principal root, and the principal root is always positive. So if you are plugging back your solutions into the equations and you get the square root of something is negative, this will be an extraneous solution. Another one is if you get the square root of a negative number. We're only working with the real number system today, which means that any solution that we get needs to be within the real number system. We're not working with the square root of negative 1. If you're taking the square root of a negative, there is no real solution to that. And lastly, if you wind up with something where you have four constants equal to each other, or set equal to each other, but the constants themselves are not equal, such that it makes an untrue statement, this is another example of when you would have an extraneous solution, because 3 does not equal 4, so whatever solution you plugged in to make 3 equal to 4, that solution doesn't work. So, all of that being said, let's take a look at our first example. And our first example is going to be 2x is equal to the square root of x plus 3. Whenever we're solving out these radical equations, the first thing we need to do is we need to isolate the radical group. So we already have our radical isolated over here. That's wonderful. The next thing we're going to do is we will raise both sides of the equation to the second power. So let's do that. Raise this to the second power, raise this to the second power. And what that will end up doing is we're going to square this side. We will get 4x squared, and this square here will undo this radical. So we'll just get the stuff out of the inside. So this side becomes x plus 3. From here, like I said, we wound up with a quadratic. So we need to move everything to one side, set the quadratic equal to 0, factor it out to find our roots. So moving everything over to the other side, we will subtract x and subtract 3. So we will wind up with 4x squared minus x minus 3 is equal to 0. Now we're going to factor this out. We multiply 4 times negative 3, so we need something that multiplies to make negative 12. But adds together to make negative 1. And in this case, that's going to be negative 4, positive 3. So let's split this up. into 4x squared minus 4x plus 3 minus 3 is equal to 0. And now we can factor by grouping. So we group off everything. Here we'll factor out 4x and be left with x minus 1. And here we'll factor out a 3 and be left with, oh, this should be a 3x, my apologies. Be left with x minus 1. That's equal to 0. And regrouping our factors, 4x plus 3 and x minus 1. So our two roots that we're working with are going to be x is equal to negative 3 over 4, and x could also be equal to a positive 1. Like I said, we are going to wind up with some extraneous solutions, so we need to go back and plug these in to make sure that they work. So let's move all of this out of the way. And let's move this up here and start plugging stuff in. We'll start with the negative 3/4. So 2 times negative 3/4 is equal to the square root of negative 3/4 plus 3. Now, we don't have to go very far in this simplification to figure out that this solution will not work. And here's why. Whenever we multiply 2 by the negative 3/4, this will be negative 6/4. And remember how I said you cannot have a square root set equal to a negative because we are looking for the principal roots, and the principal roots are positive. So we know that this solution does not work. So let's try the other one and make sure that positive 1 does indeed work. So we'll have 2 equal to root plus 3 and plug in our 1 where appropriate. We now have 2 times 1 is 2. 1 plus 3 is 4. Square root of 4 is 2. 2 is indeed equal to 2, so this solution checks out. Our final answer for this radical equation is that x is equal to 1. All right, let's move on to our next example and see if anything changes in our process. All right, for our second example, let's work through square root of 33 minus 2x is equal to x plus 1. All right, once again, we have our radical group already set, isolated by itself. So we can go ahead and square both sides. Let's do that here. Square this, and we will get the inside of here because the square will undo the radicals. We'll have 33 minus 2x. And then over here, this is a binomial, and we need to FOIL it out. If you would like a video on how to multiply polynomials or how to do FOIL or anything like that, let me know. I am more than happy to make one. This is going to be x squared plus 2x plus 1 on this side of the equation. Now we need to isolate everything over to one side since we have a quadratic and factor out, find our roots. So we need to subtract 33 and add 2x, which will make this side x squared plus 4x minus 32. All right, from here, we need something that will multiply to make 32, but will add together to make 4. All right, so what's going to work with that? Oh, negative 32. That makes a lot more sense. Okay, So to multiply to make negative 32, add to 4, that's going to be an 8 and a negative 4. So we'll split this up. X squared plus, no, let's do it this way. So we'll split this up, and this will be x squared minus 4x plus 8x minus 32. Factor by grouping. Out of here, we can pull out an x and wind up with x minus 4. And over here, we can pull out an 8 and get x minus 4 as well, making our final factorization x plus 8 times x minus 4 set equal to 0, because we did not lose that this whole thing is still set equal to 0. This means that the two roots that we could be working with are x is equal to negative 8 and x is equal to a positive 4. Let's go back to our original equation, plug these in, make sure that we eliminate any extraneous solutions, and then write out our final answer for this problem. Go ahead and clean this up just a little bit. And then let's move you over here. All right, let's check out the negative 8 first. So we'll have square root 33 minus 2 times the 8 is equal to 8 plus 1. Let's write those 8s in. And, oh, I'm so sorry. These are negative 8s. That is going to make a huge difference. We don't even have to go very far in here. Negative 8 plus 1 will be a negative 7. And we cannot have a square root set equal to a negative number. So we know for a fact that this is an extraneous solution and will not work. So let's test out the positive 4 and make sure that that one works. Root 33 minus 2 times the 4 is equal to the 4 plus the 1. 4 and 4. And that's supposed to be a 1. So from here, we're going to have 33 minus 8, which will be 25. Square root of 25. 4 plus 1 is 5. Square root of 25 is 5. 5 is equal to 5. That makes sense. X is equal to 4 is a valid solution. All right, so we will write out our solution set. X is equal to 4. And let's clean all of this up and move on to the next problem. Our next one is going to be 7 is equal to the square root of 39 plus 3x, and then on the outside of the radical, minus x. All right, so now we have a situation where our radical group is not isolated. So we do need to isolate our radical group just like we would isolate a variable. So we're going to first add x to both sides to get rid of this x over here. So we'll now have 7 plus x is equal to the square root of 39 plus 3x. From here, now we have our radical isolated. Let's square both sides. And over here, we will just get the insides of the radical. So we'll have 39 plus 3x. And then on this side, we will have 49 plus 14x plus x squared. Now we have all of our radicals gone. We do have a quadratic. Let's isolate everything over to one side and factor out, solve for our roots. We need to subtract 39 and subtract 3x from both sides. This will give us x squared and plus 11x, and that's going to be plus 10 is equal to 0. From here, This is going to be a very quick factorization because we need something that multiplies to 10, adds to 11. That's going to be 10 and 1. So we will have x plus 1, x plus 10 as our factorization here. And that's set equal to 0, which means that the two roots we could be working with are x is equal to -1, or maybe even and, x is equal to -10. Let's take these two solutions, toss them back into the original equation, and make sure that they do indeed work. So let's clear this up and move these up here. We have 7 is equal to the root 39 plus 3 times, oh no, what happened to my -1? There it is. 3 times -1 minus the -1. Subtracting a -1 is the same thing as adding a +1, so let's go ahead and switch that out now. And subtract 1 from both sides, we'll get 6 is equal to the square root of 39 plus -3. So 6 is equal to the square root of 36. 6 is equal to 6. This checks out. -1 is a valid solution. Let us try -10 and see if that one also works. We have 7 is equal to the square root of 39 plus 3 times -10 minus -10. Subtracting a negative, same thing as adding a positive, so we'll switch that around. This will be the same thing as adding 10. So let's subtract 10 from both sides to isolate the radical, and we will get -3 is equal to the square root of 39 plus -30. Now we can stop right here because we see that we have our square root set equal to a negative number, and like I said before, we're looking for the principal root, which means that this is not a valid solution. We cannot have the square root set equal to a negative number. So the final answer here is x is equal to -1. Finally, let's go through one that is a bit more complicated. We're going to go through one that has two radicals in it. And not only that, the radicals have something else attached to it, so there's going to be multiple steps. We're going to do 1 plus the square root of 1 minus x is equal to the square root of 2x plus 4. All right, this one's really interesting. We have two different radicals. If I square both sides, I'm only getting rid of one radical. But we need to do that. So the plan is going to be, let's square both sides, get rid of one of the radicals. Then let's isolate whatever radical is left over and square both sides again. Let's walk through that. First, let's square both sides. Next, we're going to get the inside of this radical. And then we are going to square this. I'm going to draw this out as a multiplication table just so you can see what this looks like. Root 1 minus x, 1, root 1 minus x. Because there's a little bit of a funky solution. 1 times 1 is 1. The root times the root will give us the stuff on the inside. And then here we'll have 1 times this will be itself. And 1 times this will also be itself. This means that after we FOIL everything out, we will have 1 times 2 of the root 1 minus x's. 1 plus 2 times a root 1 minus x, and plus a 1 minus x. So that will look like this. We'll have 1 plus 2 root 1 minus x plus 1 minus x. From here, like I said, the next thing we need to do is we need to isolate the radical and then square both sides once again. So let's do that. We need to subtract 1 to get rid of this. We need to subtract a 1 minus x to get rid of this. So let's do that. We'll have 2 root 1 minus x is equal to 4 minus 1, and then minus another 1 is 2. And then 2x minus a negative x is 3x. Next, divide both sides by 2 to get rid of the 2 right here. So divide by 2, divide by 2. We will wind up with root 1 minus x is equal to 3 over 2x plus 2 over 2 is 1. And finally, we can square both sides again to get rid of this last radical. So let's do that. Square this side, square this side. And on this side, we will just get the insides, 1 minus x. And on this side, we will get 9 over 4 x squared plus 2 of the 3 over 2 x's plus 1. All right, and those are equal to each other. Let's simplify this out just a little bit. This is a lot of fractions, so the first thing I want to do is go ahead and multiply this out. That'll be 6 over 2x. And let's multiply everything by 4 so we can get rid of our denominators. So I'm going to multiply this whole side by 4. I'm going to multiply this whole side by 4. That will give me 4 minus 4x is equal to 9x squared plus 12x. And I'm going to erase this off of here real quick. Plus 4. All right, that should be everything multiplied by 4 out of there. And now we isolate everything over to one side, factor out our quadratic. Subtract 4, add 4x, and that will make this 0 is equal to 9x squared plus 12 plus 4 is 16x, and then 4 minus 4 is 0. From here, there's not a whole big factorization thing to do. We'll just have x is what we can factor out. 9x plus 16 is equal to 0. And then from here, that means that the two options, the two things that will make this true are if x equals 0, because 0 times anything will be 0, or if x is equal to negative 16 over 9. So let's clean this up, plug these back in, and see if they work. Hopefully at least one of them will, because otherwise this would have been a gigantic waste of your time. All right, and finally to plug them back in. Let's start with the 0. We'll have 1 plus square root of 1 minus 0 is equal to the square root of 2 times 0 plus 4. And 1 minus 0 is 1. Square root of 1 is 1. 1 plus that 1 is 2. That's this side taken care of. 2 times 0 is going to be 0. 0 plus 4 is 4. The square root of 4 is indeed 2. 2 is equal to 2. Wonderful. We did it. We at least have a solution. X equals 0 is a valid solution. So what about our other one? let's plug that in. We have 1 plus the square root of 1 minus negative 16 over 9 is equal to the square root of 2 times negative 16 over 9 plus 4. Oh, I didn't close those brackets. All right, from here, what we're going to do is, let's work on this side first. 2 times negative 16 over 9 is not negative 18. What am I doing? It's going to be negative 32 over 9. And then turning that into something over 9, this will be 36 over 9. Adding those together, we will wind up with a wonderful 4 over 9 is what's left inside this radical. Now, let's work on this side over here. We'll have 1 plus this mess. Let's turn this into a 9 over 9 minus a negative 16 over 9 is going to be, 9 plus 16 is going to be 25 over 9. 1 plus this square root is equal to this square root. Now, if you remember from the exponent properties, we can distribute this radical onto the division, and this will turn into 5 over 3, because square root of 25 is 5, square root of 9 is 3. Same thing over here. This will turn into 2 over 3. Now we wind up with an interesting situation. We have 1 plus 5 over 3 is equal to 2/3. Well, this 2/3 right here is way less than 1. So if I take 1 and I add more to it, I'm still going to be bigger than 2/3. These two sides will not be equal. Since they are not equal, this is not a valid solution. It is an extraneous solution, and our only solution for this is x is equal to 0. That is all the examples I have for you today. If you found this video to be helpful, consider liking and subscribing, and if you have a topic you would like for me to cover in the future, leave it down in the comments below. As always, have a fantastic day.